All right, guys, so let's talk about a non-collusive oligopoly. This is the second part of our video. I'm going to break it down into two sections. A non-collusive oligopoly is basically an oligopoly where we don't have collusion. The firms are not agreeing to cheat. And here we can see on the diagram, we've got our average revenue slash demand curve, and it's what's called a kinked curve. So the curve is kind of elastic, and then it kind of hits a kinked point, and then it becomes really inelastic. And so this is, again, a kinked curve. It kinks kind of right here, and then it gets more elastic. So if we look at, remember that the rule is that marginal revenue is twice as steep as the average revenue. So the marginal revenue, you can see, is dropping at twice it's twice as steep as the average revenue. But when it kinks, there's this portion where the curve kind of disappears for a second. When that happens, there's going to be sort of a little bit of area here where you see this dotted line where there is no MR curve. It's going to pick back up at a certain spot and just kind of keep going. So the MR kind of is twice as steep, that kind of disappears, then it reappears. Then also you notice we've got our marginal cost curve here. We've got two marginal cost curves. So again, what we want to know, the main thing to know about a non-collusive oligopoly is why the price is rigid. And when we say rigid, we mean inflexible. Why is it that the price doesn't change? And this is what we're going to learn right now. So firstly, if the firm is at point A, so point A, this is basically, at this point, if you follow the line down, this is where MC, whether it's MC1 or MC2, equals MR. We remember that all firms, generally, if we're trying to maximize profits, we produce where marginal cost equals marginal revenue. And so because MC crosses MR, kind of in this invisible spot where we're not seeing it, that where MC equals MR, that's our quantity. So our quantity would be right here. So at that quantity, you draw the dotted line up, and it's just a little bit off here, but it's just about right. It would hit the AR or demand curve here. And then we would draw the line over, and we would know that that would be the price. So generally, the price will stay at price A. There's a reason for that. Firstly, we have an oligopolistic market. There's just a couple of firms. So if the firm raises its price from A to B, right? So basically, you can see that from here to here, the price will go up, right? The price will go up. But we have a huge drop in quantity, right? So a small change in price, big drop in quantity. Well, you can easily do the math there and figure out, well, if we have a small increase in our price, but we lose a ton of customers, the revenue is going to go way down. And there's a reason for this, as it says right here. If we're in that elastic portion of the curve, then basically the other firm would not. So, we raise our price, the other firm doesn't, everybody switches to the other firm, and we lose a lot of sales. Hence, we lose a lot of money. So we don't want to raise our price because we would be on the elastic portion of the curve, and a small change of price would be a big drop in quantity. We also want to drop our price either, though, because on the inelastic portion of the curve, if you lower your price on something that's inelastic, the price will change a lot, but the quantity won't change much. So basically what happens is if we drop our price, then our competitors drop their price. And it triggers what's called a price war. And so we don't want to do that. And our competitors don't want to do that either. And so basically we have no incentive to raise our price, and we have also no incentive to lower our price. Based on that, we basically want to just keep the price at A. So that's the primary reason why the prices are rigid or why they don't flex. Another reason also is that if the costs were to change, like let's say, one of our factories has a fire, or we have to, pay more insurance fees, to produce our goods or something. And let's say our marginal costs rise from MC1 to MC2. Well, even if they go up, we're still MC equals MR at the same quantity. So it wouldn't change the price at all. We'd still be right there, and the price would still be right there. So even if the price, or the cost of production go up, it won't probably change the price that we charge. So please note that non-collusive oligopolies generally have very stable prices. All right, let's talk about the prisoner's dilemma. You saw an example with the Khan Academy of the prisoner's dilemma, but it wasn't in an economic context. So I want to give that same sort of model to you again, but in an economic context. So, when we look at the prisoner's dilemma, we saw that it was better for the prisoners to confess, right? It was a better decision for them to confess. Well, let's look at the prisoner's dilemma, but in an economic context. So here we've got two airlines. We've got airline B and airline A, and you can clearly see that we've got two strategies, right? We can both go for a high price, the collusion price, and if both firms collude at a higher fee, they're going to both make 120 million pounds in maybe revenue. However, if they both compete and have low prices, so they're competing, through price, have lower prices, they'll make less money. So they basically have an easy choice here. Either we work together and make a lot of money, or we don't and we'll make less money. Now, but there's also, a third possibility, as you probably remember. And that is that if, for example, if airline B says to airline A, hey, let's go ahead and, we'll offer a lower or a higher price together. And so airline B makes the high price of 300, so they only get 70 million. But airline A keeps their price low. They end up making 140 million. They get all this. They get all the customers. So if one firm colludes, but the other does not, they actually have a competitive price. They get all the money and end up, or get all the customers and end up making a lot more money. Conversely, if that was to happen to airline A and airline B said, hey, let's raise our prices together, and airline A said, yeah, let's do it, and they raised their price, but airline B didn't, then airline B would make a lot more money because they'd have a much lower price, get a lot more customers, whereas airline A would not, and they would actually lose out quite significantly. So one little note, when we look at these scenarios of what are the different best options to choose, we can see that firms have choices, and the choice that both firms end up making, or the equilibrium decision, is sometimes called the dominant strategy. And I think in Khan's video he calls it the Nash equilibrium. But the dominant strategy is the strategy that both firms in the end will probably elect. So the question is, compete or collude? And I mean, if you figured out from the Khan video that both prisoners should confess, then what should both firms do? Should they collude or compete? Kids, the answer is simple. It's called do the right thing. In this instance, it's better if firms compete. It's better for them to compete based on the possible outcomes. So let's look at if we both compete, what's the best option? Well, if airline A competes and the other airline colludes, then airline A would make 140 million and the other airline would make 70. However, if airline A competes and airline B also competes, they only make 100 million. So the best option for competing for either airline would be 140 million if they compete, and the worst thing that would happen if they compete would be 100 million bucks. If they collude, the best that they can hope to get would be 120 million, whereas the worst would be 70 million. So, for example, again, if airline A colluded, they could at most make 120 million, and that's if the other firm colludes. If they collude and the other firm doesn't, then they only make 70. So when we look at the best compete option, we would make more with our best option from competing than our best possible scenario from colluding. And the worst option that would come from competing is better than the worst option from colluding. So based on this, both firms should compete. All right, so this is the end of our second lecture on oligopolistic markets. Let's do a quick quiz. Here we go. What were the assumptions of the model, number of firms and barriers to entry for an oligopolistic market? Go ahead and pause the video, say it out loud or write it down, see if you know it. Did you do it? Okay, hopefully you said that the number of firms was a few or a small number of firms, usually 2 to 5. Barriers to entry tend to be significant. What diagram do you draw for collusive oligopoly? Think about that for a moment. I want to show collusive oligopoly. What diagram do you draw? Did you figure it out? Yes, it's a monopoly. So monopoly is basically a single firm that decides to raise their prices and reduce the quantity. When two firms basically both decide to collude and raise the price, they're behaving like a monopoly. So you just draw a monopoly diagram. Next, what does a concentration ratio show? Pause the video and just think about it. Answer it and see if you got it right. Hopefully you got that a concentration ratio shows how concentrated the market is, or what market share the largest producers in a given market possess. Finally, what does the prisoner's dilemma ultimately show us about collusion? Should firms collude or compete? Pause the video, say it out loud, or write it down, and then unpause. Go ahead. Okay, did you get it? Hopefully you figured out that it is better if both firms compete, just like it's better if both prisoners tell the truth. All right, I hope this helped you, and this is basically the major concepts you need to know with oligopolies. Thanks for watching, and we'll see you tomorrow.